Draw the Lewis or electron dot structures for the following compounds. We have carbon dioxide. In this case, each carbon brings 4 valence electrons to the party. And we have 2 oxygens, each of which, if we look at the periodic table and count from the left-hand side, brings 6 electrons to the party. 2 times 6 is 12, plus 4 is 16 electrons total to work with. Again, even though carbon may have 6 total electrons, we don't care. All we care about are the 4 that are in the outermost or last row of the periodic table that contains our element. So we start with the carbon in the middle, surrounded by the 2 oxygens. The 16 electrons, 8 of them in pairs, go around the central atom, leaving us with 1, 2, 3, 4, 5, 6, 7, 8 electrons to shuffle about the other atoms. Well, this last oxygen's still a little shy. We can go through and instead of leaving these electrons up there or those electrons down there, I can move them in between. Remember that electrons between 2 atoms count for the total electrons in both. They're shared. But if I were to simply move them from the carbon to the oxygen, I'd be robbing Peter to pay Paul. I would be causing a shortfall on my carbon in trying to fix the oxygen. If I put them in between, they now count for both and make both atoms happy. Now, there's multiple ways that we could rearrange this problem and still have a complete octet, or 8 electrons around each atom. One other popular one is a more symmetric approach. Either of these would be perfectly acceptable. Next we have the sulfate ion. So in sulfate, the sulfur brings 6 electrons. Same as oxygen, even though sulfur starts off with a total number of electrons far greater than that of oxygen. And then we have 4 oxygens. Each oxygen does bring 6 electrons. Sulfur and oxygen are in the same column of the periodic table. If we add these up, 6 times 4 is 24, plus 6 is 30 electrons. But there are other electrons that we need to consider in this problem. They're the electrons that were stolen. In this case, we stole 2 electrons. And those 2 electrons add into our total. That we have to work with. So we start with the sulfur in the middle, surrounded by 4 oxygens. 8 of these 32 electrons go around the central atom, leaving us with 24. So we can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And we have used now all 32 electrons. Every atom in the compound has a full octet of 8 electrons, this would be our final answer.